All right, this is LeetCode number 12, integer to Roman. We got to take an integer and convert it into the Roman symbols that you see here. Now there's some edge cases here, so make sure you read this down here. Anything that starts with a 4 or 9 is special. So that means we're going to have a 900, we're going to have a 90, and we're going to have a 40 in here. Okay, if you only go by this, you're going to get it wrong. So let's get into this. Okay, this is C sharp, so we need a string builder. Now what we're going to do is we're just going to run a linear scan right through this thing. We don't need a master loop and do division and all this stuff. All we're going to do is we're going to start at the highest values and work our way down. This is how you would make change too. So anytime you have this kind of progressive tier of values that you need to extract, you're probably going to do this technique. So let's just work out what we need here. The thousands, that's an M. 900, that's going to be 100 less than M. So we need the 100, which is a C, CM. Then we're going to do 500s, which is a D. And then we have our special case of 400, which is 100 less than D. So it should be a CD. Then we have our hundreds, which is, what is it, a C? There. Then we have 90, which is our special case, which is 10 less than C. So that would be what, XC? It's easy to get these wrong too. All these little letters. Okay, then we got a 50, which is L. Then we got 40, special case, which is 10 less than L. And then we got 10s. Then we got our special case of 9, which is 1 less than X. Then we got a 5. Then we got a special case of 4, which is 1 less than V. And then we got our 1s, which is an I. Okay, and then at the very end, we're going to return our result dot to string. And then we're going to be done. So let's go fill all this in. You may get tired of typing and just cut and paste on this. Just remember, it's easy to get to forget to change things when you cut and paste. So we could have many thousands, so we need a while loop. Greater than or equal, make sure you get that equal in there. We're going to append this value to our string. Don't use a append line because that'll put a terminating character in there. LeetCode doesn't want that. You'll fail. So we need an M. Then we subtract the 1000. And that's the pattern we're going to use. We're either going to use a while or an if. Okay, 900, it's only going to have, you can only have one 900. So we need an if on this. Oh, I can't type. Dot append. And we need our CM. Oh, man. Crazy. Okay. What else we got? 500. Let's do that one. We can only have one 500. Could also put these on one line. I mean, you'd have two statements on one line, but you could do it. Result.append, and that's a D. Let's go to our 4. Special case, it's an if. By the way, this is an ON solution, linear. Num greater than or equal to 400. Result.append. Same thing over and over. Let's do a num minus equals 400. All right, then we got our 100. This one we can use a while because there could be many more hundreds. Special case of 90. It's an if. Yay. Okay, let's do our 50. All right, we can only have 150. Let's try the cut and paste technique. Control C, tab over, Control V, and then we got an L here. See how many things you have to change? 5, 5. Okay, save. We could do the same thing with 40. We can only have 140. Control V. Change that to a 4. All right, where's my cursor? Oh my gosh, really? Come on. XL. And change that. Okay, 10. We can have many 10s. Wow. It's greater than or equal to 10. Minus equals 10. Whoa. Okay, then we got our special case of 9. That is an IX. Special case of, well, no, that's not a special case. This is 5. Four, this is a special case. Some of those solutions out there don't account for these special cases, so be careful of those if you're watching those. say num greater than or equal to 4. And that's 1 less than v. And finally our ones, and we can have multiple ones. So that's a while loop. And that's an I. This is the second time I did this video because the first one, the sound kept cutting out. So I don't know what happened. Okay, are we done? Did we make mistakes? I don't think so. Do we run test cases? No. You know we don't. Let's do it. All right, 1 millisecond beats 99.94, beats 97.56 in memory. All right, guys, that's it. Like, share, subscribe, and make a bumper sticker. I'll see y'all on the next one.